Hi, seventh grade. We are going to be talking about finding equivalent fractions, and we're going to look at it a couple of different ways. We're going to start first with these ratio tables. And so when I say a ratio table, it's kind of like I've just taken the fractions but put them into table form. So I have my numerator on top, my denominator is on the bottom, so then we can look at the fraction like here with a numerator of 5 and a denominator of 6. This would be the fraction 5/6, which is equivalent to 10/12, which is equivalent to 15/18. And then we're going to be solving for a couple of missing parts of these fractions as well. So when we are finding equivalent fractions, we really want to be thinking about how we can scale a fraction up or down to find an equivalent value. And so, for example, from 5/6 to 10/12, if we think about what happened to get us from 5/6 to 10/12, these are equivalent, which means they represent the same value, they just look a little different. And so 5 was actually scaled up by a factor of 2. That's a fancy way to say we multiplied it by 2 to get 10. And we also scaled up our denominator. So I multiplied 6 by 2 to get 12. And so that's what can give us that equivalent fraction value of the 10/12. To look at the 15/18, I might also see, okay, so 5 times 3, if I scale up my numerator by 3, I can scale my denominator by 3 to get the 18. So now if I have my numerator as 30 and I'm trying to figure out my denominator, what we want to do is we want to look for some sort of relationship, focusing on that multiplication or division that I can use either 5/6, 10/12, or 15/18 to get 30. Okay, and so we could always come back to our original 5/6, and some of you might notice, okay, well, 5 times 6 gives me 30, and so I can scale up my denominator the same way. So 6 times 6 would give me 36. That's one way you could solve that problem. Another thing you could think of, if we look at the 10/12, some of you might notice that 10 times 3 gives us 30. So we scaled the 10 up by a factor of 3, and I could scale my denominator then by a factor of 3. And then 12 times 3, it's still going to give me 36. It's just the main point is that there's not just one way to do this problem, okay? And we could even also look at the 15, and so some of you might notice that 15 was scaled up by 2 to get the 30, and so then if you scale up the 18 by 2, you also get 36. Again, we're still coming up with the same answer, it's just a variety of different ways that you could get that answer. So then when we're trying to solve for the numerator, if the denominator is 24, we can look at any of these equivalent fractions and use them to help us solve for this. Some of you might want to come back to that 5/6, but I also want you to pay attention that like 10/12 is also a helpful fraction here. So some of you might realize, oh, well, 12 is being scaled up by 2 to get us 24. So then I can scale my numerator also. So then if I do 10 times 2, that would give me 20/24 is also then an equivalent fraction. And this last example, the denominator is 30. Again, you could look back at any of these fractions and see if any of them would be helpful. With a denominator of 30, really the best one is probably this 5/6. So if we see, okay, 6 was scaled up by 5 to get 30, and then so if we scale our numerator by 5, I'm going to get 25/30 is also equivalent. Down here we have similar fractions and a similar setup again. So the numerators are on top, denominators are on the bottom, and we're going to look at each fraction. So we have 7/9, 14/18, and then over here 42 blank, and then something 90ths. So we're going to use what we know about equivalent fractions to see if we can solve for those values. So first of all, if we look at the connections between the fractions, the equivalent fractions we already have, some of you might notice, okay, well, 7 was scaled up by 2 to get 14, and 9 was also scaled up by 2 to get 18. So whatever we do to the numerator, we want to do that same thing to the denominator. So now when we start looking, some of you, if we know our numerator is 42, some of you might see a connection between that 7 to the 42. So some of you might realize that we scaled the numerator by 6 to get 42. And so we would want to do the same thing down here. So we would do 9 times 6 and get 54. That's one way to do it. We could also use the 14/18 to help us. Really, this is 14 was scaled up by 3 to get 42, and 18 times 3 would give us the 54. When we look at this denominator of 90, we could use a couple of different fractions to help us. Probably the one that most of you would see, or the connection that most of you might see, is that 9 times 10. If we scale the 9 up by 10, we get 90. And so we would want to scale our numerator by 10 as well to get 70. So 70/90 is equivalent to 42/54, also equivalent to 14/18 and equivalent to 7/9. On table number 3 here, same idea. This time you'll notice that we initially start by scaling down. Okay, so we can scale up or down. There's no particular order. Okay. But the point is, I just want you to realize that we're focusing on multiplication and division relationships. So if I look here, going from 8/12 to 4/6, what I did is I scaled down by a factor of 2. So if I'm scaling down, that means I divided by 2. So 8 divided by 2 gave me 4, and 12 divided by 2 gives me 6. And then now if I'm missing my numerator, but I know the denominator is 3, we could use either one of these all these equivalent fractions to help us. We could use the 8/12 or the 4/6. So some of you might notice that 12 divided by 4, so 12 scaled down by 4, gives us 3, and so we could do the same thing over here to the 8 and scale it down by 4 to get 2. That's one way we could do it. Some of you might also see that 3 is half of 6, and so then this number has to be half of 4, okay? Or in other words, we scaled down by 2 to get from 6 to 3, and scale down by 2 to get from 4 to 2. Now if we have a denominator of 24, again, we can look at any one of these equivalent fractions we already have, and we can see if any of them help us figure out the equivalent fraction that has a denominator of 24. Some of you might notice that 12 scaled up by 2 gives you 24, so then you might do the same thing to the numerator. 8 times 2 is 16. That's one way to do it. If we look, I could also look at my 4/6, and 6 times 4 gives me 24. 4 times 4 would give me 16. I can even use this 2/3. So 3 times 8 would be 24. 2 times 8 would give me 16. We're still going to get the same answer. It's just a different way to do it. And if my numerator is 32 and I'm looking for my denominator, same idea. We're going to look for a fraction, an equivalent value that we already know that helps us figure that out. Some of you might realize that 16 is just being scaled up by 2, so we could scale 24 up by 2 and get 48. And that's one way to figure it out. You might also see that 8 times 4 gives us 32, so 12 times 4 would give us the 48. You could look at the 4/6 and see that 4 times 8 gives you 32, so 6 times 8 is 48. Or even this 2/3, 2 times 16 is 32, 3 times 16 would be 48. So again, we can use any one of those equivalent fractions to help us fill in a ratio table. On number 4, this is similar. We still have equivalent fractions, it's just they're not in the table form anymore. So we're still going to look for some sort of relationship as far as if we scaled up or scaled down and what that factor is. So here, to go from 6 to 30, I'm scaling that fraction up by a factor of 5. That means I take 6 times 5 to get 30. So we're going to do the same thing on the numerator.
Please excuse this interruption. Staff, it's time to release the reserve volleyball team. Thank you.
Sorry for that interruption. So 4 times 5 is going to give us 20. All right, on number 5, again, same idea. We have equivalent fractions. 12/20 is equal to 36 something. And so we look for a relationship. I'm noticing that 12 is being scaled up by a factor of 3 to get 36. So I can scale up 20 by a factor of 3 to get 60. And then the last set of problems that I want to look at, so now we have our starting fraction, and then we're going to be either scaling it up or down by a specific factor. Okay, that's given to us. So here it says scale the fraction 7/8 up by a factor of 4. When we're scaling it up, that means we're multiplying. And when we scale it down, then that means we're going to be making the numerator and denominator smaller values there, okay? So 7/8, if I'm scaling up by a factor of 4, that means I want to multiply both of these by 4 to find my equivalent fraction. So 7 times 4 is 28, 8 times 4 is 32, which means that 28 32nds would be an equivalent fraction that's scaling 7/8 up by a factor of 4. If I am starting with the fraction 4/6, then I want to scale it up by a factor of 3. That just means I'm multiplying my numerator and denominator by 3. So 4 times 3 would give me 12. 6 times 3 would be 18. So my equivalent fraction here would be 12/18. On number 8 and 9, we're scaling down. So that means we're going to be dividing by the given factor. So if I scale the fraction 4/6 down by a factor of 2, that means I want to divide these by 2. 4 divided by 2 gives me 2. 6 divided by 2 gives me 3. So my equivalent fraction is 2/3. And 12/42, if I scale that down by a factor of 3, again, I'm going to divide each of these by 3. 12 divided by 3 is going to be 4. 42 divided by 3 is going to be 14. And so I'm going to end up with 4/14. Some of these might end up with our simplest form, but not always. So we're just following the directions of the factor they want us to scale by. In this particular example, on number 8, 2/3 happens to be my simplest form. On number 9, 4/14 is not simplest form yet, but I followed the directions by scaling it down by the factor of 3. Hopefully that helps you understand a little bit about equivalent fractions. Have a great day.